Okay, good morning. So this was the problem we had from the previous session. You were supposed to think about it. Hopefully you have done a lot of progress, but let us just try to do it together. Okay, so let me read the problem again. So an athlete stands at the peak of a hill. So assume that this is the peak of the hill, and that slopes downward uniformly at angle phi. Yes, so that is horizontal, and this is below the horizontal by angle phi, and it is uniform. At what angle theta from the horizontal should they throw a rock so that it has the greatest range? Yes. So we want to fine-tune this theta in a way that this range from here to here, that it hits the hill again, becomes the maximum possible value. Yes. So first of all, I hope that you understand this is an optimization problem again. Yes. So you want to make something optimal, and here this is the range. Optimal here, of course, in this problem is maximal. Okay. So here. First of all, I want you to understand the problem here. So phi is just a constant, yes? So theta is not a constant, it can change. But we also have the initial velocity. Of course, the initial velocity is a vector. If I change theta, the vector changes. But the magnitude of the vector, what is your opinion about the magnitude of the initial vector? Yes? Of course, that is also depends on your power and your strength, yes? But assuming that every time that you want to do this test with the athlete actually can throw the ball with the same initial velocity. So that you need to take into consideration. Of course, if this model is good, I don't know, might be the biologist comes in and say that, okay, for human muscles, it differs if you want to throw the ball horizontally or a little bit upward, then you will not achieve your maximal strength. I just want you to know the limitations of your model, yes? So this model that we are considering the magnitude of the velocity really doesn't depend on the angle that we are throwing. Might be it is not very real, I don't know. Throwing ball horizontally probably for our muscles is easier than throwing them vertically, I don't know. But I just want you to know this model is not considering that. So if you want to consider that one as well, which in more practical problems probably you have to, and then you need to modify your model to take this. Another thing that we doesn't consider here is the air drag, yes? So that's probably not very realistic, but of course in these ranges it is realistic, yes? Okay, now what is your opinion about how to solve this problem? So if you want to optimize a quantity, what is your first thing to do? Yes?
In this case, I think it would be easier if we
No, in general. I'm just talking in general. If you want to solve an optimization problem, what you need first, any optimization problem. Yes? No, first, before derivative, you have to have a function to differentiate. We don't have any function, yes? So we have to set up a function, and then everything goes on, yes? So here, what is your function? And for a function, you need a dependent variable and an independent variable. An independent variable is that you start changing, and the dependent variable follows that change, yes? So it is hopefully clear for you that this range really depends on theta. For example, you can assume an extreme case that I shoot it upward, yes, and then it will go back, the range becomes 0. So this, and then if I shoot it horizontally, the range is not 0. So this is clear that the range depends on the angle theta. Okay, so then you have to concentrate on one thing, to connect the range to theta. Then you will have a function, then you have all your calculus in front of you to use those tools to optimize your problem, yes? So this is the first thing we want to do. We want to find, let me call the range R, yes? Let me call the range R, and I want to find it as a function of theta. If I can do that, then I can use the tricks we learned in Math 4 to optimize this quantity. Okay, so this is the first thing. But of course, this is also a physics problem, so we have to use physical laws. We have already done that, so we know how the projectile motion acts on vertical and horizontal direction. But before that, you have to set up a coordinate system, yes, in order to be able to talk about that. I don't know, which coordinate system do you want to choose? Yes?
I chose the tilted one.
Okay. So if you choose the tilted one, then what will happen? You will have two uniformly accelerated motions, yes? Any other suggestions? The reason that I am not for it is because usually I have the formulas in my head for the cases that we have a standard one. Otherwise, I have to recalculate everything again. But if you want, we can just start doing that. It doesn't matter actually. But we have to actually calculate everything from scratch.
I mean, the normal one, then y would be easier. The y component.
Yes, the normal one. The y component is easier, and even the horizontal component will be easier because at least you have one accelerated motion and one uniform motion. Yes, and then we already have, or at least in the formula sheet, the standard ones are written, not the unusual one. So if you don't mind, let us continue with the standard one. Okay, but of course in the standard one, we can have the horizontal axis like this. Yes, this is the horizontal x-axis. And then which one do you want to take for the vertical one? You can just take it from here upwards, or you can also take it from here downwards. Do you want to take this one in this case, I don't know. If you have solved a problem using the vertical in the upward direction, I want to follow yours so that you can see if you have made any mistakes, yes? So how many of you have taken the vertical direction upward? Yeah, so let us go with the upward direction, yes? So let me take this one, the y-axis. Okay, now can you tell me how should I find this range as a function of theta? So let me tell you, V node in this problem, V node is the magnitude of the velocity, and I assume that this is constant. Yes. So how should I calculate the range? Just give me the strategy, the details I can calculate. You want to calculate the distance from here to here, assuming that theta is given to you. So you want to find it as a function of theta. Yes?
V node multiplied by cosine of theta.
Yes?
It should be, of course, we don't take into account that it's falling
Oh, you have
past
to
the...
Okay, so that's the point, actually. That's the problem. That's a little bit making this problem harder because you have to consider that one as well. So how can I consider that one? It's very actually similar to the one that I solved. The other problem that I solved in the previous, it was uphill, now it's downhill, yes. There shouldn't be so a big difference between them. But here, in that problem that I solved last week, I wanted to find the range. But here, I not only want to find the range, I want to maximize it. But the first part, finding the range, is exactly the same, except that I solved the uphill problem, you're supposed to solve the downhill problem, yes? So what I'm supposed to do? The more or less physics is not playing any role now. Everything left is mathematics, yes?
I found the function for the curve and then intersected it with.
Yeah, that is the standard trick, yes? So if I continue this one, So in this case, if this is going to be uniform, so I can count that this is a straight line, and then probably I can find the equation for this trajectory, and if I can find the equation of this line, then I intersect them. Definitely the intersection between them is one of them is the origin, which is not interesting. The other one will be interesting, yes? And I will find that, yes? Okay, but now let us start with the simple one. Can you write an equation for this straight line for me here? You are doing math specialization, yes? Yes?
Tan of theta is the angle.
No, I'm just talking. So theta is this angle with the horizontal.
All right.
Phi is the angle from the line to the horizontal.
So y equals tan of phi.
Okay, so might be.
No, minus.
Okay,
Yeah.
minus is correct, I think. Why is that? So let me just tell you here, if you have a line, if this angle is alpha, if I ask you what is k value is tangent of alpha, yes? And if I have this type of lines, if this alpha is here, again k is tangent of this alpha. So I always consider the angle that my line makes with the horizontal and in positive direction, yes? So if you see this phi is not playing exactly the role of this alpha. So if you want to imagine that, yes, this is the angle that you have to consider for the slope. Yes? So a slope is this. Slope is the angle from the line to the positive part of the x direction. If you find that angle, calculate tangent of that angle, it gives you the slope. And of course, in this case, it is clear the slope of this line you already know is negative, and alpha is an obtuse angle, so it is in the second quadrant. Tangent of alpha in second quadrant is negative, so everything is actually consistent. So is that clear? So this is the angle that I want to calculate. So what is that angle? It's pi minus phi, yes? Because from here up to here is pi, 180. It's a straight line, yes? So up to here is pi, but we have to stop phi degrees before that, yeah? So that is pi minus phi. So the slope of this line is tangent of pi minus phi. But hopefully, what is tangent pi minus phi? As Ruben mentioned, tangent pi of minus phi is actually minus tangent phi. Yes? If we had this in trigonometry, yes? This is the trigonometry of supplementary angles. If I have two angles that are supplementary, sines are the same, cosines are opposite. So if I divide them, tangents also become opposite. Yes? Is that clear? So that is the k value. And this is a line passing through the origin. So the k form of my line gives me the k value plus the y-intercept. Y becomes k is minus tangent phi. What is y-intercept? 0. Yes, so that is the equation. That was the simple one. It didn't need any physics at all. But these equations we mathematicians cannot discover because they are consequences of experiment which is coded in the Newton's second law. But we have already done that, so we know that probably what is the equation. I don't know, probably you have it in your notes. I think I have it in my memory, so I use it. If I'm wrong, please tell me. So this is a parabola. If you go back and see your notes, so this would be minus g over 2 v naught squared cosine squared of the angle that the initial velocity makes with the horizontal. So that is theta into the here. And then you have x squared here, and then you have tangent of that angle theta times x. Yes? So, yeah, if you check it, please. We had this before, yes. But of course, might be I have chosen different names for those angles. What I mean, if I'm understanding correct, theta that I am putting here is the angle that the initial velocity makes with the positive x direction. Is that right? Minus g, so yeah, that's right. Yes? Okay, so now we have that one and this one. So what I am supposed to do, I have to intersect these two. Definitely you get the origin, and then you get another point which is of interest. Yes? Okay, now let us do like this. Instead of really encounter, let me change my strategy a little bit. I solved this problem in a different way. Let me assume that I solve this system, an equation of the system is this one, another equation is this one. And then assume that I solve and find x and y, okay? And then one x and y are 0 and 0. The other one, I call it x and y, yes? I haven't solved this, I want to make the algebra simpler. I realize that I probably could do the algebra simpler in the previous case. So I am pretending I solved the system and found x and y values. This is x value and that's y value, yes? So remember, this x and y values satisfy this equation and that equation simultaneously. Okay, and then I am interested in the range. And the range is the distance from the origin to that point, yes? So the distance, so the range, of course, here in this case, which is a function of theta, as you will see, is a square root of x squared plus y squared. Yes? So it is very simple to use it just right now. Instead of solving the system, I pretend that I solve the system and I have my x and y. Yes? So x and y satisfy this equation and that equation. So this means that I can continue and write, instead of x squared, I write x squared, but instead of y squared, I put this in. This minus sign will go away and this becomes tangent squared phi x squared. Yes? And then you see this is very simpler, the way that I did it last time when I checked the video. So here you actually can take x squared out. This becomes 1 plus tangent squared phi. Yes? And then 1 plus tangent squared phi is a very nice combination. This is 1 over cosine squared phi. So this becomes square root of x squared over cosine squared phi. Yes? So let me continue here. So then this becomes absolute value of x cosine theta. So that is my, cosine phi. First of all, do I really need, so I have to, there is no exception. Whenever you have this, you have to write absolute value. But then, in this problem, I don't need absolute value. Why? Because you see that I am working in this quadrant and that quadrant. In both of them, x is positive and phi is an acute angle. So its cosine is positive. So because of that, I safely remove this. So you might say that, okay, I was supposed to find r as a function of theta, but apparently I found x as a function of phi. So I found r as a function of phi. How do you answer this? Because I am supposed to find r as a function of theta. This is a little bit strange because phi, I cannot change the slope of the hill unless you're the god, yes, but you cannot change that. So how is that possible? I was supposed to find r as a function of theta. I found r as a function of phi. I'm just playing with the questions, yes. I want to keep you alert because these questions are easy to answer. So what's the answer? By the way, these are very important questions because it gives you some way of thinking through the problem if you are making mistakes, to catch your mistakes. So here, I have expressed r as a function of x and phi. X is related to y is related to theta. So it means at the end, x is a function of theta. And then r is also a function of theta. Is that understandable? So you see, I got r of theta like that, a very simple equation for it. But in the numerator, x is the x-coordinate of this point of intersection, which satisfies this and that. Even here, you can see that x is a function of y, because x is related to y, and then y is related to theta. So this is a function of theta at the end. Okay, so this I have a very simple formula here. So let me just put it in a box. So r theta is x over cosine phi. But this is not very useful because from now on, I want to differentiate my function with respect to theta. If I don't see theta explicitly in my formula, it's not that useful. Yes? So, but at the end, I have to go for it and find x as a function of theta. Okay? So how can I do that? What is the standard trick to do that?
Just equate.
Yeah, we have to do that. Because when I want to write x as a function of theta, if you see how many variables are involved in these two equations, phi is constant, x is variable, y is variable, and theta is variable. I want to connect x to theta, so it means that I need to get rid of y. So it means that I need to eliminate y. So I replace y here, so this becomes minus tangent of phi, x equals to minus g over 2v naught squared cosine squared theta, and then I have x squared and then plus tangent of theta x. Of course, I know that there are two solutions for x. One is 0, which I don't need to solve to see, but I want to look for a non-zero x. If I want to look for a non-zero x, I am allowed to divide everything by x because I'm looking myself for the non-zero one. So I want you to understand the logic. So I just divide everything by x. On the right hand side, this becomes and then finally, now you can see it more clearly that x is really a function of theta, because I want to find x, it means that I have to make x alone. So I move it to the other side, it becomes g 2v naught squared cosine squared theta, and then x equals to tangent theta is there, so you move this one to the other side, so it becomes positive tangent of phi. And then what I am looking for, I am looking for x. So what happens? So x becomes this expression multiplied by that divided by g. So I would write it like this. Is that right? And now you can explicitly see that x is a function of only one variable, because g is the gravitational constant. It's constant. V naught, because of that explanation for our model, V naught is also constant. It's the velocity. This is the speed, and phi is a constant. So the only variable left is theta. And as you see explicitly that really x is a function of theta, and when you put it here, r becomes a function of theta. So finally we have r. Hopefully we will not need these. So finally we will have our formula for r theta, yes? So r theta is equal x that I found here divided by an extra cosine phi. So yeah, I hope that you agree with me. If I divide this by cosine phi will go here, yes? So this becomes 2v naught squared, as I would write g cosine phi. I intentionally want to separate cosine squared theta and put it here because this is my variable. And then I have tangent of theta plus tangent of phi. So, and this is usually, you didn't have this level of difficulty in Math 4. This is a function that you're supposed to optimize. Yes? Now I hope that you agree. Don't let these other letters distract you. This is just a function of one variable, and that is theta. Whatever letter you see left here, they are constants. Yes? So we were able to find this r theta. And of course, if you remember, if I want to optimize, I need also an interval for my variable. Yes? So what is the interval of theta here, which is reasonable in this physical problem? Yes? I don't know, some people might say that that is also good to consider from here to 90 degrees, because that guy should be crazy to shoot it backward, yes, to find the range, to maximize the range. So I think it's reasonable to consider that. Might be this is also good to consider. I don't know, do you intuitively think that this guy shouldn't shoot it downhill?
Yes.
So should we exclude that? First, my impression was saying that theta is somewhere between 0 and pi over 2, because more than pi over 2 is ridiculous, because that person is shooting backward, yes? But this is not so unreasonable to consider, yes? From minus phi to pi over 2, yes? I don't know, do you feel that there is no chance for this guy to shoot a little bit below horizontal to reach to the maximum speed, to the maximum range? Okay, let us see what happens. Now, I need to differentiate this function. So these are technical problems. So each problem has its own problems you need to solve. I don't know. And you need to be skillful in algebra to do it a little bit easier. Do you have any suggestion for me how to proceed to maximize R? Because we want to take the derivative. If in this form I want to take the derivative, it is possible. But which rule do I need? I'm just reviewing things. I want you to know that you know a lot mathematics actually. So it's quite advanced mathematics. It's more than the high school level, but this is not something that you don't understand. So if I want to take the derivative exactly in this form, which rule of derivative I need? Yes?
Chain.
Not yet. Before the chain rule. Chain rule will be needed, but before the chain rule I need one more rule.
The product rule?
The product rule, because this is a function of theta. This is also a function of theta. I have been multiplying them. So this becomes the derivative of this one. In that case, I need chain rule multiplied by that plus the other way around. But can we avoid this? So always do not start algebra before thinking a little bit, because then it will be problematic. I prefer to multiply. It's better to avoid the product and the quotient rule as much as we can. So I will continue and write 2v naught squared. Is that right here? No power of 2, yes. G cosine phi. And then I multiplied this. In your head, tangent is sine over cosine. One cosine will cancel one of these cosines. It becomes sine theta, cosine theta, yes? And then I multiply there, it becomes tangent phi. I put constants on the left usually, and then cosine squared theta. And then I can differentiate. But before differentiation, this is a product rule. The derivative of this one multiplied by that plus the other way around. But of course, this combination should be very familiar to your eyes now. You know what is this? Of course, if you want, that's up to you. You can use the product rule. But I really want you to appreciate these differences, because if the problem is hard, then it becomes really messy if you don't pay attention to these details, yes? So what is this?
Double angle.
Yes, 1/2 of the double angle. So this is 1/2 sine of 2 theta. I hope that you see that the derivative of this is easier to do than this one. Of course, the results will be the same. But here, you can just keep it like that. Okay, and now I differentiate finally. So r prime theta becomes equal. This is just a constant, so I just pull it out. Cosine phi, and then this becomes 1/2. The derivative of sine 2 theta is cosine 2 theta, but multiplied by the derivative of 2 theta because of the chain rule, which will give me a 2 and cancels that 1/2. So this becomes simply cosine 2 theta, yes? And then this one, what is the derivative of this one? Can you just answer it for me? What is that?
The minus 2 sine double, like minus sine 2 theta.
Minus sine 2 theta. Yes? Because the 2 goes down, cosine theta, but by the chain rule I have to multiply by the derivative of cosine, which is minus sine, and then it becomes minus sine 2 theta. So this becomes minus tangent phi sine 2 theta, yes? This is the derivative. So you see that the algebra became actually simpler. If you didn't pay attention to this and you want to go forward like a bulldozer, it doesn't work, yes? You get stuck with a very big stone. So you have to pay attention when you want to do the algebra. And then there is one trick to it, which is not coming from mathematics, and this you have to love, yes? You have to love the calculations, and then it will come, actually. If you don't care, say that, okay, the computer can do it for me, of course. The computer probably can do it for you, but then you have to understand what is going on. Okay, then I put this one equals to 0. Then I want you to tell me what should I do. So r prime theta is equal to 0. But this is a constant, and it is not 0. So the only thing is that this should be 0. So this means that cosine 2 theta minus tangent phi sine 2 theta equals to 0. Okay, so now I am facing a trigonometric equation. But this is a trigonometric equation. First of all, I hope that this is not distracting you. Yes? This is comparable to this equation. If I ask you to solve this, or if I ask you to solve this, technically there is no difference between them. Because here, phi is a constant, here tangent phi is constant. So these are very important things that you have to pay attention. Otherwise you will say that, okay, I have a tangent there, what should I do with that tangent? Apparently we don't need to do anything with the tangent. Do you understand this? If I ask you to solve this, you don't care about phi, your concern is about these two. But if I give you this, you change the way you think, that is wrong. You have to correct yourself, yes? So these two problems are actually completely similar. Okay, in this case, what is your proposal? Probably the same strategy will work there. Yes?
Divide by cosine 2 theta.
Yes, divide by cosine 2 theta. Yes? If you divide by cosine 2 theta, of course there are some things you need to be careful. If I divide by cosine of 2 theta, it means that I am assuming that cosine 2 theta is not 0. And that is probably good, because if cosine 2 theta is 0, then sine 2 theta is either 1 or minus 1. And then it means that either tangent of phi is 0 or minus tangent phi. So tangent phi should be 0. But tangent phi is not 0 because phi is this angle. Yes? So it's on the safe side. As you said, you said by divide by
Cosine 2 theta.
cosine 2 theta. So if you divide by cosine 2 theta, but why didn't you divide by sine 2 theta?
Because tangent.
I understand. The reason that you do this because in your high school education you don't study a little bit about cotangent. So every time you want to make a tangent. Cotangent is the other way around. It's cosine over sine. Yes, but yeah. But let me divide by sine, okay? But that's completely. So let me follow yours, okay? Cosine 2 theta is 1 minus tangent phi, and then what do I have there? Is tangent 2 theta equals to 0. Yes? And then what is your unknown? Your unknown is theta, so you have to make it a low. So what you have to do, you have to move it the other way around. So tangent phi, tangent 2 theta becomes equal to 1. So tangent 2 theta becomes 1 over tangent phi. Yes?
Isn't it minus 1 on the right side?
No,
Because
I moved this one to the other side, but wrote it in the other direction.
Okay.
Yes? But this one, at this point, you shouldn't really be disturbed about solving this equation. So, for example, what is the answer to this equation? Don't forget, tangent phi has the same role as 5. every time you forget. If I give you 1 over 5 and I ask you to find theta, the way that you think should be exactly the same way that you think for this problem. So I think that you still let these things distract you. Yes?
And 2 theta equals tangent inverse.
Yeah. You see, when I give you the hint, you realize this is the same. But I don't know. Could you anticipate this is the rule before I give you the hint? Yeah, that's good. If you don't, you have to correct it yourself. There is no teacher that can teach you this. Yes? So 2 theta is that one. So you say that, okay, 2 theta is tangent inverse of 1 over tangent phi. And then I am looking for this, so this theta is 1 over 2. Yes? Yes or no? That's correct. That's my theta. Yes or no? Somebody yes or no?
Yes.
Yes, it is yes. So theta is this one. But there is one problem with this theta, and that is ugly. Yes? Usually, if you can think more beautiful, you really need to pay attention to it. Now, can you do it beautifully? Because you know why? If I want to solve the problem technically, I am not done yet. Because, of course, because this is a physics problem, you know that when I get a theta, it might be a fake one. It might be a terrace point. This is mathematics. Mathematics doesn't care about physics. Yes? So this might be a terrace point for this function. This function, by the way, is complicated. You don't have any clue how to draw the graph and things like that. So this is really possible that that theta is a terrace point. Or it might be a minimum. Yes? Or it might be a maximum. Yes? So that is the point. From a mathematical point of view, you need to convince yourself this is really the maximum one. The minimum one is clear, yes? This cannot be the minimum one because of the nature of the problem, yes? Do you agree with that? Because if I want to make it minimum, there is one theta I can think about, and that is 90 degrees. Yes? And this is definitely not 90 degrees, is it? If theta becomes 90 degrees, then 2 theta becomes pi. Tangent of pi is 0, and 0 cannot be equal to this fraction. So this theta is not, we are on the safe side, that's not the minimum one probably. Of course, this is not still clear. Might be you say that I can find another angle for the minimum, that is that one. But this is not possible because there is only, I got only one point of interest, and that point is this one. And I already know theta equals to pi over 2 makes it a maximum, makes it a minimum. So that should be either a terrace point or a maximum point. So then you see that from this perspective, working with this ugly angle is not very recommended. If you can do it algebraically simple, you have to do it. Do you find a way to do it? Okay, so you have to think here a little bit. Even though I told you that give the same rule as 5 here, but I was not 100% correct because this form has some advantages for solving this problem, and that is this one. So this might be you haven't had experience for that. I want to guide you through that. So 1 over tangent phi, I hope that you agree, it is cosine phi divided by sine phi. Yes? Because that is the reciprocal. I want to make this a tangent again. Can you make it a tangent? Because this is not tangent. In tangent, sine should be up, cosine should be down. But here, cosine is up and sine is down, but still I want to make it a tangent. Tangent of another angle, probably. Which is? I told you that in... so do you remember, if I have 2 complementary angles, what will happen? Sine of one of them is equal to the cosine of the other one. And I also told you that if I have 2 complementary angles, do you remember tangent alpha has some relation with tangent beta? What is that? Even if you have forgotten, you should be so quick to reproduce it. Yes? So if I give you 2 complementary angles,
and I ask you what is the relation between sine and cosine of these angles, you would say sine of one of them is equal to the cosine of the other one, and vice versa. Now I'm asking you a question about tangents. I have explicitly mentioned that when I was teaching the chapter 2 in Math 4. But you don't need that. I hope that you remember this fact, that sine of one of them is cosine of the other one. Is that right? Hopefully you remember this. And that is enough to understand what is the relation between tangent alpha and tangent beta. Yes?
Tan beta is 1 over tan alpha.
Exactly. And that's exactly what I want, 1 over tangent of something. Yes? So in other words, instead of cosine phi, I can write sine of the complement angle. This is the complement of phi. So cosine of phi is equal to sine of that, and sine of that is equal to the cosine of that. Understandable? Yes? But now, what is the name of this combination now? Is tangent. Yes? So it is tangent of pi over 2 minus phi. And now look, I have equality of 2 tangents. That's also standard in trigonometry. I have 2 tangents equal and I want to solve the equation. You remember that I told you that if you have tangent of a box equals to the tangent of something else, this happens if and only if what is inside the box is some integer number times pi plus what is inside the circle. Yes, that was the formula. So you remember we had 3 standard trigonometric equations: equality of sines, equality of cosines, equality of tangents. For the equality of the tangents, we had this formula. So now we have it actually. Tangent of a box unknown is equal to tangent of this one. So that is the circle. Okay, so let us just not to clean here. So let me clean this one now. I might need something here. So what happens here? 2 theta is equal to n pi, where n is an integer, plus pi over 2 minus phi. And I divide by 2, so this becomes n pi over 2 plus pi over 4 minus phi over 2. But of course, in this case, you know that theta is probably, what are the numbers that, so this is why I need to have this range. So the maximum value of theta reasonably is pi over 2, yes? So it means that, can I choose, for example, let me choose the values for n. So if I choose n equal to 0 first, theta becomes pi over 4 minus phi over 2. Yes, so that's acceptable. If I choose n equal to 1, what will happen?
Pi over 6.
No, so pi over 2 plus pi over 4 is how much?
9.
3 pi over 4, yes? Yes? Yes?
Nu försöker jag titta ner. Nu bara, Mats och så. Du ska ändå.
It's not understandable. Yes, I put 1 here and I calculate this, yes? Okay. And then if you put 2, I hope that you agree that 2 will be beyond the range, yes? And if I put minus 1, what will happen? This becomes minus pi over 2 plus pi over 4 is minus pi over 4 minus phi over 2. Okay? So these are the numbers I can, if I continue. Okay, so let us, I think that this is our answer. Because I need it to be in this range. So I need theta to be somewhere between minus phi, if we consider this is possible, up to which point? Up to 90 degrees, yes? So I don't know, can you convince yourself that this one is definitely is in this range or not? Yes? Can you convince yourself of that? So let us see. So I want to check, is pi over 4 minus phi over 2 in the range that I am interested in? This is a question mark. So how should I check this? So this one is the smaller, this is clear, yes? Pi over 4 minus a positive angle, so this part is clear, yes? But is this part clear? Let us check. If I move phi over 2 here, it becomes minus phi plus phi over 2 is smaller than pi over 4, then this becomes negative phi over 2 is less than pi over 4, yes? Is it true or false? Yeah, that is definitely true, because phi is a positive angle and so that is definitely an acceptable answer in the range. Yes? Is that right or not? Yes? Okay. Now, what are the other answers? Do you think are there other answers? Because if there are two angles, might be this athlete can have two options to reach to the same. But is it true or false, do you think? Other angles. What do you think about this one? But this is a little bit tricky now, I understand, yes? Because it depends to this angle, yes? Might be. So this 3 pi over 4 minus pi over 2, is it really smaller than pi over 2? Because that is 135 degrees. We want to make it smaller than 90 degrees. And this cannot happen. Why? Because phi over 2 cannot reach to 45. Because if phi over 2 reaches to 45, it means that phi reaches to 90. Yes? But this phi 90 means that you actually should fall from, you yourself fall down. Yes? So you cannot do that. So that's also not possible. So, I think this. I hope that you agree with me that this is the only possible solution. You can also check the negative ones. So this means that this is the only candidate in that range, but you have to convince you that this is really a maximum, not a minimum or something like that. How do you do that? So let me ask you one question. Did you understand what I did here? So I just solved this equation. I got infinitely many solutions. But this is a physical problem, so I have a limited value. So I have a limited interval for theta. I assume that this is a reasonable interval for theta, yes. And then I realized that, for example, this one does not satisfy this, yes, because if it is supposed to satisfy this, theta phi should be larger than 90, which is not reasonable in that case. You have questions?
I don't understand one thing. Why did you choose n equals to 1? If it, you didn't know.
No, because this is a math problem. So I have to find. So it gave me this. I put the derivative equal to 0. It is an immediate consequence of the math. I have infinitely many solutions. Yes.
Yeah. No.
But I have to check which infinitely many solutions is in the interval of my interest.
Okay, so when you chose those three, you didn't know which one.
No, we didn't know.
Yeah.
I was suspicious about this. But I have to check the other ones. I will not continue here and there because if they go, I'm making things worse. Yes, so I will not actually. I'm making things worse. I don't consider the more negative ones more positive ones. But I was a little bit suspicious about this, and I realized that no, it is not in that interval. And then hopefully you can see that this is not in that interval. So I will only take this one. But still, the problem mathematically is not finished because it might happen that this is a minimum, not a maximum. Even though we know this is not a minimum, because minimum value occurs when theta is 90 degrees, yes? So that is the maximum. So that is the answer. It's very, very simple answer. And I hope that you agree this is more beautiful for our brain than this one. But they are the same, actually, yes? So the angle that this guy should do it, so for example, if phi itself is 45 degrees, then this angle is 45 minus 45 divided by 2. So it is 22.5. So this athlete should train himself or herself to be able to throw it with angle 22.5 degrees. Yes? The closer that this person gets to that angle, the chances of getting a higher value for the range is more. Is that understandable? Okay. But the point is that Another question is good. You want to see, so this is practically usually more important than answering what is the maximum range. Maximum range is not, it depends to your actually capabilities of your bodies and everything. But here, if I want to ask, okay, what is the maximum range that this athlete can reach? And then how do you answer that question? We know that to reach to the maximum range, this athlete should train herself or himself in a way to be able to throw the rock with this particular angle. Yes? And probably that is achievable. If you practice a lot, probably you will learn how to do that. And now the question is that this is more important. But sometimes you want to actually calculate in advance, okay, do you have any chance to go and compete with others if your range is not that much good or it's very good? So then you need me to calculate this range really. How do you calculate the maximum range? How do you calculate the maximum range? It is clear if this is going to be, and by the way, there is another way that you convince yourself that this is really a maximum. Do you remember what was the trick? And that is called the second derivative test. So you take another derivative of this one, which is easy, because that's just the cosine. This is a constant, and that's sine. And then you plug it back here to see if it is positive or negative. So if you don't mind, to be sure everything is right, let us just do that one as well. So can you take the second derivative? Because I want to improve your skills, you know. So r double theta is what? That's constant, so let's just write it down. Okay, divided by g cosine phi. And then the derivative of this becomes minus 2 sine 2 theta. The derivative of that one becomes minus here 2 tangent phi cosine 2 theta. Do you agree or not? Yes? So that is the second derivative. And if you don't mind, I can take minus 2 out. It becomes minus 4. Yes? And then I put this angle into the function, second derivative. R double prime of that angle, pi over 4, minus phi over 2. So let us see. This becomes minus 4 v naught squared g cosine phi. And then I put 2 theta here. I multiply it by 2. It becomes sine of 90 degrees minus phi plus tangent of phi cosine of pi over 2 minus phi. Okay, do the calculations for me. So what is the answer if I want to simplify it? So it is minus 4 v naught squared divided by g cosine phi. And then what's the answer to this? Immediately, sine of pi over 2 minus phi is? Whenever I ask you these questions, you remind me of the engine. It's going to start in the morning in the winter. What is this now? Come on. Yeah, it is cosine, just immediately. Yes, cosine phi, yes, plus tangent phi. And then what is this one? Sine phi, yes? Okay, but then you need to convince yourself this is really negative. Yes? Is it negative? Because you know that maximum happens if the second derivative at that point is negative. So you have to convince yourself that expression in front of you is negative. And it is very easy to convince, yes? Because cosine phi is positive, phi is an acute angle, so tangent phi, sine phi, everything in this combination is positive. Positive, 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 and this negative was crucial. So this is really negative, and so this confirms that this is really a maximum. Don't worry about it, yes? Is that clear? Okay. But if I want to make it more beautiful, can you do it in your head? What is the simplified version of this? It's like you don't need, because what you needed is to see that it is negative. And we confirm that this is negative. But can you do it in your head, simplified? No, don't write. In your head. It's not hard, come on. So sine, another sign here is sine squared. There is a cosine here which will be multiplied here, cosine squared, added to that sine squared 1. Finished. And then that cosine squared, cosine comes here, yes? So it is minus 4 v naught squared g cosine squared phi. And this is more beautiful. Yes? And it is easier to see it is negative because everything included here is positive, so this should be negative. You have to improve your skills, okay? So we finalize this problem, but still I want to calculate the maximum range, which was not in the problem. I don't know, for some reason. I don't know. Might be this is complicated to calculate, and this is why they haven't asked for it. But I remember yesterday I wrote that one. So let us see what happens. So what is the maximum of R now? What should I do? I think everything is straightforward. What I have to do, I know what makes range maximum. This is this number. So I put it back in the range function to find the R maximum. And then let me ask you the question how we can calculate this again. I intentionally want to keep it because I realize now I can do it a different way. And you have also studied that. Let us see if you appreciate it. So R, the maximum range, let me write R maximum is equal to, yes? R maximum is equal to what? So what I have to do, I have to keep this constant. Okay, which one do you prefer? Do you prefer to put it here or to put it here? Because we also simplified this a little. Okay, so let us put it here. Why here is better than here? Why did I choose this one? These things I want you to learn. This is not hard. Because this angle, this was pi over 4 minus pi over 2. I hope that you agree if I multiply it by 2, it becomes more beautiful. It's pi over 2 minus pi. And pi over 2 minus pi is good working with. Yes, I prefer to put it here. So this becomes 2 v naught squared divided by g cosine phi. And then you put 1/2 and then you write sine of 2 times the angle. Let me just do it in my head. So it becomes pi over 2 minus phi. Agree? And then of course with tangent of phi I cannot do anything. But if you want to put it here, that's okay. But then I will have problems. Yes, it becomes cosine of pi over 4 minus phi over 2 squared. And it will be over my head. Yes, because I don't have any formula for that. I have a better formula for this, which is cosine phi. Yes, so you see, beauty is a good guide. Yes, guide you towards it. But this one remains ugly. Is there any way to get rid of it? Yes. This is how you start appreciating the formulas. So, do you remember we had a formula that I told you? Do you remember how we integrate? How can I find a primitive function for cosine squared? Do you remember? I told you 2 formulas. Yes? Now suddenly it becomes relevant. Yes? So what is that formula? Do you remember? I have to clean this over and over again because still I'm not sure what I need. So here, do you remember I told you that there is 3 formulas for cosine 2 squared. Yes, 2 theta. One of them is this one. Yes? And now this cosine squared, I've moved 1 to the other side and divide by 2. Yes? Yes? So this is cosine squared theta. In terms of cosine of 2 times of the angle. And that is better, because if I can do that, the same thing will happen here. So now, can you tell me what to do now? So tangent of phi multiplied by, instead of cosine this, I would write 1 over 2 plus 1 over 2, but cosine of 2 theta. So it means that I multiply theta by 2, it gives me the same thing. Yes, is that understandable? Now, can you tell me what is the answer? So g2 naught squared over g cosine phi. And then this is sine of what? So this is cosine of phi. By the way, you see there is a 1 over 2 here, 1 over 2 there, 1 over 2 here. I take it out and I cancel it with these 2. Yes, it is easier. And then it becomes tangent of phi. What is left? I factored 1 over 2 out, so 1 is left. I factored 1 over 2 out, so 1 is left. But cosine of pi over 2 minus phi has a better name. Yes? So this is the maximum range. Okay, but can you make it more beautiful? Probably not that much, but at least one combination. If I multiply this, it becomes the same combination here, yes? So this becomes tangent of phi plus tangent of phi sine phi. Yes, so you can simplify it a little bit. Let us see how it goes. Yes, I don't know if we can simplify it that much, but we can probably try to do our best. So for this tangent of alpha, which is left, let us keep it like this. Let me write it sine of phi cosine phi. Yes, that is that tangent of, but this combination can be simplified as I told you before, yes? Do you remember what is the answer? Can you do it again in your head? What is this plus that? So sine squared, the cosine will be multiplied here, cosine squared added becomes 1, and then you have cosine phi in the denominator. So actually it becomes a little bit more beautiful, yes? Because now this becomes v squared, and then 1 plus sine phi, and then divided by g. So I will have 1 plus sine phi divided by cosine squared phi. This is good. So this is your maximum range. Yes? So it means that if I want to maximize my range, I have to train myself to cast the rock like this, with that angle, and the maximum that I can achieve is this one, not more than that. Yes, is that clear? And of course now you realize it depends. I hope that this is reasonable. Could you predict that your maximum range will depend on these parameters? To the V naught, you should expect that, yes? Because it is clear, if you are more powerful, you can throw it with higher speed, and of course it will increase. And by the way, it's a quadratic term. So if you train your muscles a little bit so that you can throw it faster, it increases the range with power of 2, not linearly. Yes? So the speed, so you really need, so after all these things, you see that this enters the problem with the power of 2. So you really need to train your muscles first. Yes? And then G, could you predict that G should also be in the problem at the end? Definitely it would be easier for you if you'd go to the moon and throw this, yes? Because G in the moon is 1/6, so, and that was clear, it should be in the denominator. If the pull of the gravity is smaller, you have the chance to send it to higher ranges, yes? So you should be able to predict that. So in principle, if I have G upstairs, then I realize that, okay, I might have made a mistake in my problem. Yes? And what about phi? So the behavior in phi is more complicated, yes? So you need to see how phi looks. So one way to do it is to draw the graph of this function to see how it looks like, and then you see that how it will enter the problem. Okay, but now let me ask you one question here. Let us go back to this formula that okay, this, nothing is on the board, unfortunately. We have to simplify. So I don't need a derivative anymore. So let me just get rid of the derivative here. So do you remember that was my r theta? I simplified r theta here, and instead of cosine squared, I put this one. Yes? And then 1/2, 1/2, 1/2, I pull it out. So let me write your function again. This 1/2 that I pull out will cancel that one. Yes, and then what happens here is sine 2 theta, and then you have plus tangent phi, and then plus, so times 1 plus cosine 2 theta. This is the formula that you get for r theta. Yes. Can you find the maximum of r theta without using derivative at all? That is my question now. Yes. So of course we did it using the derivative. It was lengthy, but by the way, now you see that is quite advanced mathematics, by the way. So now you understand that your knowledge of mathematics, if you want to use it, it is quite at a good level. Yes. Now I'm asking you this question. I give you a function. Usually, we have to use the derivative to find maximum or minimum, yes? But for this particular problem, can you find the maximum of this function without using the notion of the derivative at all? Okay, so let me let you think so that I clean the board. And then let me keep the maximum here so that we can compare. Hopefully we haven't done any mistakes, otherwise we spoil the joy of that, yes? But anyway, so this, let us keep it here. I don't think you remember, but let me write something, okay, what do you want to say?
You know, in the interval,
Yes?
if you would want to find the maximum, either it's in the beginning of the interval or in the last part, or in one of the maximum points.
Local, so
Local.
This problem shows that it is a local point.
Yeah.
Because it didn't occur in the endpoints.
But then you would need the derivative after all, because you
No, that's my question.
yeah.
Yes, in general you really need the derivative, that's clear. But this form, I will write something on the board, might be to remind you about something in chapter 2. Yes? Yes, do you remember something? Okay, if you remember, let me ask you, what is the maximum of this function? Do you need derivative to answer? Derivative is one way, of course. But do you need a derivative to answer the maximum of this particular combination of sine and cosine? What is the maximum? What was the maximum? Do you remember? I called it amplitude probably at that time, but that amplitude is the highest value that this can achieve. Yes. Again, you are starting the car. Yes. No, this is the square root of a squared plus b squared. Yes. Square root of a squared plus b squared. Do you remember? If you have forgotten, you need to remember how I did that by pulling it. It was a little bit strange how I did it, but I hope that I could convince you at that point that this is the amplitude, yes? So the maximum value is this, the minimum value is negative of that. Yes? Okay, but now how this problem is related to this, but now everything is in front of your eyes. So now I ask you, is this problem related to that problem at all? If yes, how do you connect them? This you should be able to answer because everything is in front of you now. Now I just want to see how do you think, because it's important. I don't know. How do you think about the problem? You want to connect this to that. How do you think? What is the first step you really do in your mind? Because I want to really correct you if you're thinking it wrong. So how do you connect? Do you think about this part? No, good. That is incorrect. So let us write. So r theta is v squared. Why don't you think about it, by the way? Because that's a constant. And for maximum and minimum, if I find the maximum and minimum of this, I just multiply it by that. That's very obvious. So I don't care about it. Okay, what do you think about this internal term? And you want to connect this somehow with this idea, not exactly this. So what do you do?
Multiply tan.
Yes, exactly. You multiply the tan. So, but you have some goal in your head. You want to have this combination in front of you by this. So what do you do? So can you tell me, Denise, yourself, so how do you do that?
I switch the order.
Exactly. So you see, this is not hard, and then you are learning. Okay, good. Cosine 2 theta. And then, of course, I cannot just rule it out. I have to cope with it, yes? I have to write it down. Is this idea similar to this? It is. What is playing the role of A in this problem? 1. What is the role of B?
Tan.
Tangent of phi. Can tangent phi play the role of a constant? Yes, it is a constant. I told you, don't let these things distract you. But do I have any problems here? Why not? Because what's your goal? Don't forget the goal. The goal is to find the maximum. If I can find the maximum of this part, because that's a constant, I add that constant to that maximum, and then I multiply by that, I will get the maximum. Okay, so what is your prediction now? So it means that I concentrate momentarily, I forget about everything except this, I want to find the maximum. We already know the formula. So what's the formula? It's a squared, which is 1, b squared, which is tangent squared phi. Again, this combination appears. And that is what? Do you remember? 1 over cosine squared phi, but absolute value, cosine phi is positive, so this one. Yes? So this is then, if I ask you what is the maximum, so I hope that you agree with me that this is constant. Yes, this is constant. So the only thing that I have to do is to replace this with its highest value. But the highest value according to this is that. Yes, so it becomes 1 over cosine phi. Yes? So is that the same thing there or not? This is tricky. No, that's exactly the same thing. Do you agree? Because tangent phi is sine phi over cosine phi. And then what I do, I would write v squared, and then I have g, and then this is sine over cosine, so it becomes cosine phi, 1 plus sine. But there is another cosine here that I multiply it here, and you see I get the same answer. It is, I really recommend you, if you're interested in mathematics, don't give up. Just solve the problem and forget about it, I solved it. It's very good to see the same problem from really different perspectives, because it will teach you and remind you about a lot of things. So I think that you see that what part of this problem was physics is very little. Yes? And the only physics involved in that problem, what was the only physics, do you remember? What was the only physics information we used?
It's finding acceleration on the...
No, in the way that I solved it today.
Oh.
Not from scratch, yes?
Limiting the range.
Limiting range is coming from physics, so that's, let me correct myself, but what I wrote on the board, the trajectory, yes, the trajectory is not predictable by just mathematics. It means that if you are sitting in an island and try to do math. If you're super genius, you can discover a lot of things mathematically, but you will not be able to discover that because it needs experiment. Yes? So that formula that I wrote here, y is equal to minus g, I don't know, do 2v naught squared cosine 2 theta x squared plus x tangent theta. This is of course a mathematical equation, but if I want to find that, that is coming from physics. Yes? But except for that, everything else is mathematics. And of course, it is always good if you are doing a math for a physics problem, you need to consider that if your answer also makes sense physically. For example, at the end, we got that and it is reasonable. In the beginning, probably we could not anticipate that v naught squared can appear. By the way, you can also predict that v naught squared can appear, yes, somehow. How? You have studied that in physics, I'm sure. Probably not exactly the same combination, yes?
When we calculate the formula for the distance,
No, yes?
has nej, skoja.
No, there is I think you have heard about it. That's called dimensional analysis. Have you heard about it? So an equation should be dimensionally consistent. So I cannot have a length on the left, a speed on the right. Yes, because I have to compare the same type of quantities. Yes. So let us, by the way, try to do some dimensional analysis here. So here. Okay, by the way, I give you this as example before cleaning this. I was able, this is a very good problem, please think about it, yes? This, I was able to get the same value for the maximum without derivative. But what is the problem left? Could I solve the problem demanded in this problem using just this trick? Because in the question, they haven't asked about the maximum range, they have asked about the possible angle theta giving rise to that maximum range. Yes? In this second method, I only was able to find the maximum range. Now, this is my question for you. Can you use the second method to also find theta? Yes? Yes or no? Is the question clear? With derivative, I was able to find theta and I was able to find R max. When I switched the technique to use this idea, I was able to get the R max back without the derivative. But my question is that using this idea, can I still find that theta, pi over 4 minus phi over 2? That is an open question for you to think about. Yes? But now let us go back to the dimensional analysis. So range is a length. Yes? A speed, what are the dimensions of a speed? A speed, for example, in MKS unit is meters per second. So it means that this is a length divided by a time. Yes? So this is LT minus 1. So this is the way. If I write the dimension, in physics they use square brackets. So this means that they are looking for the dimensions of this quantity, and we learned that this is length times T inverse. Yes? And then, so here, what is G? What is the units? What is the units of G? What are the units? I'm always confused about this. Yes.
M divided by S squared.
M squared. Oh, n over squared. So it becomes what? What is that? LT minus 2. Yes? That is the dimension of that. Okay. And now, what is the dimension of R max? Is length. Yes? Okay, so you want to have length with some combination of V. We don't know, for example, how many powers of V will appear, so let me put it N. Multiplied by some power of G. Yes? N. So I know that, by the way, this part is dimensionless, that's just a pure number. So this means that if I don't know, this is some predictions, if I want to write range as a product of these quantities, I will have something like this. But if the dimensions of V node is this, I raise it to power n, it becomes L to the power of n, and T inverse to the power of n, which is minus n, multiplied by G. G is what? L to the power of m, T to the power of minus 2m. Yes? And now L to the power of m, L to the power of m becomes L to the power of n plus m. And then you have T to the power of minus n minus 2n, minus 2m. Agree? So this combination should be this. But the power of L is 1. So this means the power of L should be 1. But there is no time dependence here. So it means that this should be 0. So this means that this should be 1. And this n plus 2m should be 0. Yes? I multiply it by minus sign. And then you solve the system. Yes? You solve the system. You subtract them. What is the answer? What is n and m? If I multiply this by minus sign and add it here, m becomes negative 1. And n is 2. Yes? Now go back here. n should be 2, m should be minus 1. So this should be of power of 2 appearing, and this should be a power of minus 1 which goes to the denominator. So this is a really powerful trick in physics, and you have to be very careful and sensitive. So it have saved my life a lot, because you do some calculations. If the calculations are really lengthy, so for example, if I get G upstairs, I immediately realize by this is not really big mistake. I have to go back and just check. I have probably flipped somewhere so that the G appears in the numerator. Because if G appears in the numerator, it is dimensionally inconsistent. Because you see that V squared to the power, so V squared is of this type, L squared T minus 2. And if G goes there, it becomes L T minus 2. And then if I multiply that, it becomes L cubed. And then I will have T to the power of minus 4 for something that I expect to be just L. So this is dimensionally inconsistent. And whenever this happens, it is not probably a very deep mistake. It means that that is just a very, very minor miscalculations, or very big one, I don't know. But at least you immediately realize this combination should appear. Yes? And I hope that you see that even in the normal range, for the if I remember the formula correctly, it is this one. And then you see the same combination appears for the range, a standard range. And that is not a coincidence, because we need this combination. Any other combination is not dimensionally consistent. Yes? Okay, so I think we have to stop somewhere. Okay, no questions? But there's still one question is open. How can I get this angle using this second method without derivative? This will teach you a lot of mathematics. Thank you very much.
Do we have the next lesson in the aula?
No.
We stay here.